All right, today is day 5, and today we're solving multi-step equations with variables and the distributive property on both sides. So the goal of today's lesson is that you'll be able to solve multiple multi-step linear equations with variables on both sides using the distributive property. We are going to make this as complicated as possible, but you got this. So remember, the steps are distribute, and then it's going to be combined like terms, and then move the variable term to one side, add or subtract, multiply or divide. So these are going to be our 5 steps, excuse me. So step number 1 is distribute. The first thing I look for whenever I'm solving an equation is, first, I have an equal sign, so that tells me I'm solving an equation. I should probably draw a line through it. Now I look and see, do I have parentheses? I do. I have parentheses here. I have parentheses here. So now I use the distributive property. The distributive property states that I can distribute the value out in front of the parenthesis to everything inside the parenthesis, and I use multiplication. I use multiplication to eliminate this parenthesis. 4x, 4 times x is 4x. 4 times negative 2 is negative 8. And then this is plus 3x. I'm going to go ahead and write in pink anything that I don't interact with. Here, 2 times 5 is 10. 2 times negative x is negative 2x. Don't forget about that negative. Do not drop that negative. Okay, that step is done. Step number 2 is combining like terms. So again, I'm only focused on a single side of the equation. I'm not moving stuff back and forth right now. Over here, there is nothing I can combine. I have 10 and I have negative 2x. There is nothing I can combine between those. Over here, I have a 4x and I have a 3x. I can combine those. This is positive 4x. That is plus 3x. 4x plus 3x is 7x. Nothing happens with this negative 8. It just comes and chills out over here. Nothing happens with this 10 and this negative 2x. That step is done. Step number 3, move the variable to one side. I have variables on both sides. I can't have that if I'm solving an equation. I need to move it so it's on one side, and I always want to move the smaller value. I have positive 7x over here. I have negative 2x over here. So I'm going to move this value over here. And when I move it, and it changes its sign. Instead of being negative, it now becomes positive. What I am doing is I'm doing step 4, but I'm doing it strategically only with variable values. So I am adding 2x to both sides. When I add it over here, it eliminates it and goes away. And over here, 7x plus 2x is 9x. Nothing happens with the negative 8. Nothing happens with the 10. Now I start concerning myself with moving and solving for this. And all of this up here was just to get to here, just to have a single x value or single variable. Now that I have a single variable, I isolate it and get it all by itself. Add or subtract to move stuff away. I have a 9x minus 8. I want to move this negative 8. So the easiest way to move it is, instead of negative 8, I do positive 8. This zeroes it out. It makes it go away, which is what I want. 10 plus 8 is 18. This becomes 9x. Now I multiply or divide to solve. I divide by 9 because right now my 9 is multiplying the x. It's saying I have 9 x's. I don't want that. I only want a single one. So I divide by 9 on both sides, and I'm left with x equals 18 divided by 9 is 2. So what I'm saying is, out of all of the numbers in the entire real world system, all of the numbers, the only one that will make this true is if its x value is number 2. If it is any other value, if it's 1, if it's 0, if it's a billion, This will not work. So therefore, I should be able to check that. If I say I'm going to rewrite this equation, I'm going to say 4 parenthesis, I'm going to substitute in 2 for my x value. So here, I'm rewriting this equation right here, minus 2, parenthesis, plus 3, 2. I'm running out of space here, so I'm going to solve this, and then I'm going to solve this. And these two values should end up being the exact same. I'm saying if I input this into here and here, I should end up at the same spot. Negative 2 minus 2 is 0. So this becomes 4 times 0 plus 3 times 2, which is 6. 4 times 0 is 0. This equals 6. So I'm saying, I'm predicting that if I put in a 2 right here, I should get a 6 out. Let's check. 2, 5 minus 2. So if I substitute in 2 right here for this x value, I need to get 6 out. And then I know my solution is correct. 5 minus 2, that's 3. 2 times 3 is 6. So yes, those things are true. So therefore, I know my answer of 2 is correct. This, I could type this entire thing into Desmos here with that 2 value to verify that if I wanted to. That's another way that we can check. Okay, so here we're going to practice and we're going to show all of our work. So again, the very first thing I'm going to say is, and I'm going to write it right down here in the middle, so in that way I can check mark on both sides. We distribute, we combine like terms, we move, we add and subtract, we multiply and divide. Don't call me after midnight. Step 1, distribute. Do I have parentheses? I sure do, so I'm going to distribute those parentheses. I'm going to distribute over those parentheses. The 4s go here. The 3s are going to go here. 4 times 4a is 16a. 4 times negative 3 is negative 12. 3 times 5a is 15a. 3 times negative 3 is negative 9. The biggest mistake I see kids making here is when we drop these negatives. Don't drop those negatives. All right, distributing, done. Step number 2, combine like terms. So here, I'm looking to see, are there anything I can combine over here? 16a and 12, can't combine it. 15a and 9, can't combine it. All right, sweet, that step's done. Love that step, it's already done. All right, step number 2, or 3, excuse me. Move the variable to one side. So I look for my variables. I have 16a over here. I have 15a over here. I always want to move the smaller variable. So I'm going to take this and I'm going to move it all the way across. And when I move it, when it crosses that equal sign, it becomes negative. So this is negative 15a. 16 minus 15 is a single a. Nothing happened to that negative 12. Nothing happens to this negative 9. That 15a, it went away, it went over here. Okay, cool. That move step, done. Step number 4, add or subtract. Now it's about isolating the variable. So now I'm going to say, okay, now I'm moving everything away. My variable, I had an a up here and I had an a over here and I had a bunch of parentheses and all this other junk. Now I just have it over here. So now I'm going to start moving things away from it. Instead of subtracting 12, I'm going to add 12. I'm going to do the inverse operation. The inverse of subtracting is adding the opposites. I'm left with just a over here, which is what I wanted. I wanted this to go away. Negative 9 plus 12. If I have 12 and I take away 9, I'm left with 3. There is nothing to multiply or divide because I only have a single a value. So that step is done. So now I can check it all. I'm saying that of all the real numbers, positive, negative, decimals, all the real numbers, if I use 3, that's the only thing that's going to solve this and make this true and make that this side is going to equal this side. If I pick any other number besides 3, this won't work. So let's check. 4 parenthesis 4, I'm going to substitute using purple, times 3. Minus 3 equals 3, parenthesis 5. Instead of A, I'm writing a 3. Minus 3. I have substituted in this A value and this A value with 3's. Okay, so now let's go ahead and we're going to do our normal solving, which is our normal order of operations. Parentheses, exponents, multiply, divide, add, and subtract. So 4 times 3 is 12. 5 times 3 is 15. I'm going to try and take care of this inside parenthesis first. So this is left with 4, 12 minus 3 equals 3, 15 minus 3. 12 minus 3, that's 9. 15 minus 3, that's 12. 4 times 9, that's 36. 3 times 12, that's also 36. So that works. That's true. So therefore, my value is correct. And that is something I can do on any sort of test or homework, as I could go ahead and check this to make sure that my answer is correct. Here, they try to make this extra complicated, but it's not. Just because it has a dreaded fraction. Don't worry, it'll be perfectly fine. Step 1, stick to our steps. Distribute. I have parentheses. I'm going to draw a line down this equal sign. So I'm going to go ahead and distribute over these parentheses. Distribute the 1/2. Distribute the 2. Don't do anything with this 6f. The 2 is distributing over the parentheses. All right, now I know they're going to freak out because there's a fraction, but it's okay. You read it like this. Take half of 6f. Well, half of 6, that's just 3. F. Half of 12. Well, half of 12 is just 6. Boom, done. That fraction isn't all that scary at all. Nothing happens with this 6f. It's not distributed. Nothing's done with it. Plus 2 times 1, 2. 2 times negative f, 2 and negative f's. Boom, distributing, done. Second step, combine like terms. On the left side, I have 3f plus 6. I have no like terms over here, so I can't combine anything. That's done. Over here, I have 6f and I have negative 2f, so I can combine these things. If I combine them, 6 minus 2 is 4, so this becomes 4f. Nothing happens with this 3f plus 6. Nothing happens with that positive 2. There was no combining of like terms there, only here. Boom, done. Step number 3, move the smallest variable. So here I have 3f's, here I have 4f's. I want to move the smallest variable. So I'm going to take this one and I'm going to move it over here. When I take it and move it, instead of positive 3f, it becomes negative 3f. Nothing happens to that 6. It hangs out. 4f minus 3f is 1f, so that becomes f. Plus 2. All right. The moving step, done. Add or subtract. So now, again, all of this stuff up here was just to get all the variables all combined to one value. Now I can go ahead and solve, and now I can go ahead and isolate this variable. So instead of positive 2, I'm going to subtract by 2. This leaves me with 4 equals f. There is no multiplying or dividing again. So again, my multiplying and dividing is already done for me. That step's done. So out of all of the values in the real world, all the numbers, positive, negatives, decimals, zeros, all of it, 4 will balance this out. And if I tested this, I'm going to rewrite this whole thing. 1/2, 6. I'm going to input my 4. Plus 12 equals 6 Substitute my 4. Plus 2. 1 minus. Substitute my 4. F. I always, if you notice, I always substitute in with a negative, with parentheses. This is why. So in that way, I know that there's multiplication here, and I know that that negative shows up here. Okay, so let's go ahead and do this. There's nothing happening with this 1/2. 6 times 4, that's 24. Plus 12. Equals 6 times 4, again, that's 24. Plus 2, 1 minus 4, that's negative 3. Okay, let's simplify again. Order of operations, deal with everything in the parentheses first. 24 plus 12, that's 36. This becomes 1/2 times 36. 2 times negative 3, I put a plus, but it should have been a minus, is negative 6. Half of 36, I'm going to write in pink down here. I think it'll show up the best. Half of 36 is 18, and 24 minus 6 is 18. So that works out. That's true. So again, 4 is my correct value, and I know it works because I was able to show that it works. Again, this step, this last step that we did where this check is, this looks super, super complicated. But if you go in and you type in this into Desmos, along with your solution, substituting it in, all you're looking for is that they match on both of them. We'll practice that in class. We'll talk about special solutions. Here's what happens when you solve for special solutions. I'll go through this really quick. We distribute. This becomes 2.5x plus 10 equals 2.5x plus 10. So I distributed. There's no combining of like terms. So then I do step 3, which is move. And when I move, I subtract 2.5x from both sides. And I'm left with 0. And I'm left with this goes away and this goes away. And all I'm left with is 10 equals 10. That means it doesn't matter what number you pick for x. Every value works. So that means there are infinite many solutions. So again, it doesn't matter what value you pick for x. Every single time, this will be true. If you pick 0, it will work. If you pick 10, it will work. If you picked a billion, it will work. Here, as we can predict, this meant all the numbers work. Doesn't matter what you pick. If there's no solutions, what we can kind of predict is what's going to happen is no matter what numbers we pick, it will never work. And here's why. I distribute this. So when I distribute this, I have 6y minus 30. I distribute this. I have 20 plus 6y. I move my variable. If I notice, they're the exact same. So when I move them, I'm left with negative 30 equals 20. Because these eliminated themselves. So now, instead of having a true statement, which means every value works, here I have a false statement. And when a false statement shows up, that means nothing works. So when your variables can be eliminated if the values that are left behind are true, they're equal to each other, 10 equals 10, then it's infinitely many. If they're not true, negative 30 equals 20, then there's no solution whatsoever. It does not matter. Every single number that we try, no number will ever work to make this equal to this.